This video is going to show you how to remove, check, and reinstall wheel speed sensors, which are part of the Antiskid system. So we're going to have to remove the hubcap here, which is just held on by a snap ring. You can remove it with a flathead, but be careful, they tend to fly if they're not covered by something. So the wheel speed sensor is held in place by these two bolts going through the wheel axle. So in order to gain access to the wheel speed sensor, we're going to need to remove those two bolts, which I'm doing right here. So after we get those two bolts removed, we can take the wheel speed sensor out. I'm just referencing my maintenance manual. The wheel speed sensors are part of the anti-skid system. They rotate with the wheel to detect any change in acceleration. They're on all main landing gear wheels. So it's just connected by a basic cannon plug with safety wire. This is the rotating armature or rotating blade that rotates with the wheel, giving our wheel speed for each individual wheel assembly. So I'm just going to remove the safety wire to get everything unplugged. So after we get the cannon plug disconnected, we can see that on the wire harness side we have male pins, on the sensor side we have female pins, and then we have our rotating blade on the other side, which fits into the hubcap. So the little prongs on the hubcap go over the blade there and it rotates with the wheel assembly. So that's what gives us our wheel speed. So how it works is the wheel speed sensors detect any rapid deceleration or slowing of one of the main landing gear wheels. Slowing indicates that the wheel isn't gripping the runway, and that can cause a brake lockup or a skid. So the wheel speed sensor sends a signal to the control unit, which then sends a signal to a control valve, which takes away brake pressure from the wheel that's experiencing a skid, so that the wheel can come up to speed with the other wheels and prevent brake lockup or loss of directional control. And here I'm just making an extension out of safety wire on our multimeter probes. Since we're dealing with female pins, I want to make sure that we're getting a good solid connection to those pins. So basically when we're troubleshooting an anti-skid system, it's easiest to start from the wheel speed sensor because they're pretty accessible. So we're just going to check to see if they're operating as they should. I'm starting with DC voltage. There's DC and AC wheel speed sensors, but in this case it is DC voltage. So I'm just getting our little extensions into the pins there. And we're not going to get a reading without rotating the blade. So that's what we're going to do. And I have the contacts in there. And as I rotate the blade in the direction of the wheel rotation, you can see the voltage spikes. And it's really only it's switching between volts and millivolts right now. But it's really maximum 3 volts from how I'm able to spin it just on the ground there, which I'm doing it's called the flick test. And since this wheel speed sensor is DC voltage, if you flip the contacts, instead of having negative on B, if you have your negative on A, you'll get a negative voltage reading, which I'm going to try to show you here. So we're flipping it, you can see it's negative rather than positive. So now we're going to check our resistance. So we're going to select ohms on our multimeter, and we have our probes on the pins A and B. We're going to keep them there, and you'll see that the ohms jump up to about 300. So from 200 to 300, which is pretty normal for this DC wheel speed sensor. If we did rotate the armature or the blade of the wheel speed sensor, you would see an increase in resistance. Nothing too crazy, just a slight increase in resistance. So that's how we could check out the wheel speed sensors, and from this test it seems that they're operating. If this was a real world scenario and you had a problem with the anti-skid system, after checking the wheel speed sensors you would check either the control unit, which is just the brains of the system, the computer, and you would also check the anti-skid control valve, which is electrohydraulic. So the control valve, being electrohydraulic, receives electrical signal from the control unit, and the valve either directs or takes away hydraulic pressure from the brake assemblies, depending on what's happening in the system. So the anti-skid system is comparable to the traction control system in your vehicle. The difference is you can typically experience a skid and you can feel it in your car, but on large planes with multiple sets of main landing gear, you're not going to be able to feel a skid on a single wheel. So how it works start to finish is the wheel speed sensor detects any rapid deceleration or slowing of any of the main landing gear wheels. That deceleration indicates that the wheel is not spinning, or it's completely stopped or slowed excessively. Once that happens, a skid, loss of directional control, or brake lockup could occur. So the wheel speed sensor detects that deceleration, sends a signal to the control unit or the computer of the system, and the control unit sends a signal to the control valve, which then takes away hydraulic pressure from the brake on the wheel experiencing the skid. So it releases the brakes, allowing that wheel to come up to speed with the rest of the main landing gear wheels. And that will effectively prevent a skid, prevent loss of directional control, and brake lockup, all of which could be very dangerous on a plane carrying hundreds of passengers. So it's essential that we maintain this system properly and know how to troubleshoot it. A couple more things to note on the anti-skid system is that it automatically disarms in flight. So when weight is taken off wheels, the squat switch in the main landing gear will tell the aircraft that it's airborne, and it will automatically disarm the anti-skid system to prevent the pilots from applying the brakes before touchdown or in flight. Now I'm just finishing up safety wiring the cannon plug to the wheel speed sensor so that it doesn't come undone during flight. So you can insert the sensor back into the main axle. Just make sure the holes on the sensor are lined up with the axle so you can put the 2 bolts through. I got the 2 bolts through, torqued them to spec, and now we're ready to put the hubcap back on. It has this really annoying snap ring that can be challenging. I saved you from having to watch me struggle with it, but I eventually got it back on and we're ready to go.